Welcome to the GreenNet Lumberyard tutorial. In this tutorial, we'll learn how to use agent-based modeling in GreenNet. We start by creating a new agent type, navigate to the simulation setup, and drag agent type onto the simulation pane. We will name this agent type log, as it will represent the logs moving through the lumberyard in our simulation. Next, we need a method to spawn new agents. In GreenNet, agents are spawned by spawn nodes. You can create a spawn mode by opening the basic logic blocks menu and inserting a node. We will use spawn interval. This allows us to spawn an agent on a set interval. Next, we must name the block, assign an interval time, which we'll set to 10 minutes, and select the agent type to spawn, in this case logs. In GreenNet, agents move through the network of nodes, exiting one and entering the other. In this simulation, we will add a delay node after the spawn. This will cause the agent to be spawned in the spawn node and move into the delay node, where it will wait until a certain amount of time has passed. Next, we create the delay block by going to the simulation menu and adding delay time. We can set the time of the delay block to 10 minutes. After this, we can create our new run. This will allow us to run the simulation. We do this by going to the Run tab in the simulation menu, adding a new run, giving it a name, a duration, and then clicking Run. This will start the simulation, and we can see the agents moving through our blocks. Playback controls are found in the bottom left of the simulation. This can be used to adjust the speed. Step 2. Resources. Resources are used in GreenNet to model certain aspects of a simulation that need to be used by an agent, but are constrained on quantity. This could be tools, key pieces of equipment, or key personnel. In GreenNet, we can create a new resource by dragging the resources onto the simulation pane. Next, we give the resource a name, in this case saw, and a quantity, 2. This means 2 of these resources will be available. An agent must request the resource using the resource request block, and then release it after it's finished using the resource release block. We can assign the type of resource the agent will request and release in these blocks. Next, we simply link the blocks into the node network by connecting them to the output of the spawn node and the output of the delay node. This means the agent must obtain the resource before entering the delay node. If the agent cannot obtain the resource because they are already in use, then it will idle in the resource request node until one becomes available. We can adjust the delay time to 15 minutes. This should mean that only 2 agents should be able to enter the block simultaneously because they will be constrained by the resource. If we adjust the spawn time to 5 minutes, then we should be spawning more agents than we can deal with. This will show a bottleneck in our system. Next, we can rerun the simulation. By running the simulation, we will see that each agent must wait until a resource becomes available for use. The agents that cannot obtain a resource remain in the resource request block until it is granted. Step 3. Conditions. Conditions are used in GreenNet to control the flow of agents through the blocks. This can cause agents to go down branching paths based on certain simulation parameters and states. In this simulation, we can assume there are 2 different methods of cutting logs after they have entered the lumberyard. In this simulation, after the first 10 logs have been cut using method 1, any subsequent logs will be sent down the second path to use method 2. To start, we add a condition 2 block. This is a condition block with 2 exits. We can do this by dragging it onto the simulation pane. The node network then needs to be rearranged to fit the new condition block. We'll place it after the resource request block, as this will require that any agent going through either method must have the saw resource. This block can be linked to the other blocks and given a name. Next, we can copy the original delay block. This will allow us to simply and easily connect 2 different paths to the condition block. Once the blocks are created, we can connect the outputs of the condition block, both the true output and the false output, and the outputs of the delay blocks back into the release request block. Next, we need to set up the condition for the condition block. In this case, we will add an input, which can be dragged onto the simulation pane to act as a variable. We will name this block method 1 and use it to keep track of how many logs have gone through the first method. We'll give a default value of 0. In GreenNet, each block has an onEnter function and onExit function for each exit of the block. These functions can be used to execute snippets of code in the block. We will use the onEnter function for the first cut log block. This will add 1 to the method variable each time an agent enters this block. Next, we configure the condition. The condition statement must be in the form of a return statement. This statement says that if method 1 is less than 10, the agent should leave through the true exit. If method 1 is greater than or equal to 10, then the next agent will leave through the false exit. Now, if we rerun our simulation, we will see the first 10 agents will use the first method, and the subsequent agents will all use the second method. This technique can be used to simulate far more complicated processes in GreenNet. Step 4. Other agents. You can add different types of agents in GreenNet to simulate more complex interactions between agents. In this example, we will add a new type of agent called truck, which will deliver the logs to the lumberyard. We will add a new agent type and call it truck to represent the new type of agent in our simulation. Next, we will repurpose the spawn logs block to spawn our trucks. We will rename it, assign a new time of 1 hour, and set the agent type to trucks. After this, we can reposition the blocks in the network to make space for the new logic that will need to be applied for the trucks. We'll add 2 delay times, one the travel time of the truck, and the second the unloading time for the truck. We'll set the time for the travel to be 10 minutes and the unload time to be 5 minutes. Next, we will need a method for creating the logs. We will use a split block. The split block takes in a single agent and produces multiple agents out of the 2 exits. In this case, we will keep the original truck as one of the exits and make 20 new logs out of the second exit. To do this, we will click the Keep Original box. The first agent type can be left blank, as it will be the original agent, and the second agent type can be set to logs. We link the second exit into our log processing blocks and create a delay block for the truck to enter after leaving this block. The truck will then leave the site and we'll set this time to 10 minutes. Finally, we can rerun the simulation. We will see now that the trucks spawn on a much slower interval. As the truck reaches the split blocks, new logs are entered into the plant where they wait until they can be processed. This allows us to capture a far more dynamic interaction in the lumber mill. Step 5. Parameters. Parameters can be used to modify certain aspects of the simulation with each run. This can provide a powerful tool for users of our simulation to change things without having to modify the underlying logic of the simulation. We create a new parameter by dragging the parameter block onto the simulation pane. We'll create 2 in this case. The first parameter will be the spawn interval of the truck. We'll call it truck interval, set the suffix to hours, and put it default to 1. The second will be the log cutting time. We'll call this cutting time, suffix of minutes, and set the default value to 10. We will then go to each of the blocks respectively and select our new parameters from the drop-down menu. This means the block will use whatever value the parameter is assigned when the simulation runs. Next, we create a new simulation run. This run will have our new parameters in it. We give it a name, a duration, and expand the parameters menu to view our new parameters. The parameters can be changed here. We'll set 1.5 hours for the truck interval and 5 minutes for the cutting time. When we rerun the simulation, we see the trucks arrive much more slowly. However, the logs are processed much quicker. Users of our simulation can modify these parameters to try different scenarios. Step 6. Datasets. Datasets are used in GreenNet to capture certain variables at a set interval throughout our simulation. This can be used to produce output charts and time series data that can be exported from our simulation. To create a dataset, we drag the dataset item onto the simulation pane. The dataset will be given the name throughput, and we'll use it to track the number of logs that have been moved through our lumberyard. Along with this, we'll add a new variable to keep track of these logs. This variable we'll call total cut. The default value will be 0, and we will set a callback function in the resource release to add 1 to this variable every time a log moves through the system. We will then tell the dataset to track this variable and set a save interval. In this case, the interval will be set to 1 minute. This means the dataset value will be produced every minute. Next, we go to the graphs page. We add a new dataset graph and select the value of the dataset to be throughput. When we run our simulation, this graph will be populated with the output of the dataset. In this case, we see that the dataset shows the number of logs processed over time. This is the end of the guided portion of this tutorial. We recommend that you use this as a base to create further modifications to the simulation and explore many of the features of GreenNet. We hope you have enjoyed this tutorial, and thank you for watching.